Let's talk about the substitution property of equality from lesson 1. We're also going to talk a bit about the addition property, mainly how to tell the difference between them and how to identify when each one is being applied. This is, again, meant as a supplementary video, so adding on to and clarifying what you already know about these properties. If you're looking for an introduction to these properties, this isn't the right video for you. Make sure you've read through lesson 1 before looking at this. So, our substitution property of equality tells us that if A equals B, then A can be substituted for B in any equation. So, if I had some equation B plus 5 equals 10, and I knew that A equals B, I could substitute A for B and say that A plus 5 equals 10. I made a substitution, okay? The addition property of equality tells me that if A equals B, then A plus C equals B plus C. So notice here I'm not substituting anything, I'm adding C to both sides of the equation and saying that it's still true. For example, if I knew that A equals B, I could add 5 to both sides of the equation. If A equals B, then A plus 5 equals B plus 5. That's the addition property of equality, okay? Let's look at an example. I think most of us know how to apply these properties, but it's a matter of identifying them in someone else's work. So let's take a look at this example. Let's say we're given that y equals 5 and y minus 2 equals x. What if I asked you to identify the step where substitution takes place? That would be this step right here. Notice that the y became a 5. I was able to do this because I know that y is equal to 5, so I substituted y for 5. That's the step where my substitution happened. And then of course I solved and got x equals 3, but the most important part here is what step did my substitution happen in? So substitution happens in that line where we actually make the change using the equality that we know. Let's do the same thing for addition. Imagine that you were looking at this example. And I asked you in what row and what step was the addition property of equality applied? That would be this step, right? This was a step where we actually added a value to a given equality. We knew that x minus 3 was equal to 10. In this step, we added 3 to both sides of the equation because we knew that because of the addition property of equality, we knew that the relationship would hold. Okay? So again, really important to be able to identify the step where substitution or addition is happening. Often students get confused between the two and mix them up. Again, just kind of talk it out loud. Imagine that you were given a question that asked you to identify, what property is being applied in this step. Just think about what's happening. Is a substitution taking place here? Well, no, but we did add 3 to both sides. Is an addition taking place here? No, we just swapped out one value for an equal value, okay? Now, this normally comes up in situations like this, with this proof, for example, where you're given your column of statements and you're given your column of reasons, and sometimes some of these reasons are left blank and you have to fill them in. My point of creating this video is to make sure that you feel comfortable and a little more conscious of filling in reasons. So for example, notice that the substitution property of equality comes up in this proof. And now I know you can't see the full proof, you don't even really know what we're trying to prove, and that doesn't matter. But I just want to point out, notice that in this proof, this relationship was established, and so was this one. And then in this third step, a substitution took place because this relationship AC equals AY plus YC was used. This was the original ratio, AC over AY, but AC was substituted for AY plus YC, and hopefully you can see that. So instead of AC, they plugged in AY plus YC for that numerator. Same thing with the other one. We know that AB is equal to AX plus XB, so AB became AX plus XB in this substitution. Okay? Notice also that the subtraction property happens. I know we didn't talk about that in detail, but again, and if you look at this, I think you could probably identify it. We went from 1 plus yc over ay equals 1 plus yb over ax. Well, I think it's pretty clear that they subtracted 1 from both sides of the equation to cancel that out, right? And the reason that they were allowed to simplify to this step was because of the subtraction property of equality. Okay? So again, make sure that you're aware of these properties and be careful when you label them in your statements for proofs. Again, substitution property, if A equals B, then I can substitute A in for B. Addition property, if A equals B, then I can add some value or some constant or a variable to both sides of the equation, and that relationship will still be true.